Hello and welcome to today's video on the formal definition of a limit using the intuitive approach. Now recall that to do this we're looking for a specific epsilon greater than 0, find a delta greater than 0 so that the absolute value of f of x minus L is less than epsilon whenever 0 is less than the absolute value of x minus a is less than delta. Now that 0 is less than just means that x cannot be equal to a. So that's why we have the double inequality for that. Now remember here the plan of attack is to start with what I've highlighted in blue and then transition that to looking like what I've highlighted in yellow. And when we get it to that point, the delta will be the number that we have on the right hand side of that inequality. So let's look at our first example, which is a linear case. The function that we're talking about is 2x plus 4, which is a linear function. Now just to make sure that we understand each of the pieces of this, our function f of x is what you're taking the limit of. What that whole limit is equal to, that's your L. And the value that x is approaching, that is your A. So now when we look at what's highlighted in blue, we start with the absolute value of, in this case, our function is 2x plus 4, and then minus our L here is a negative 6. So minus a negative 6, that's what's in the absolute value, and it's less than the epsilon that they give us in this particular question. So our epsilon is 0.05. Now we're going to work through the steps. First we're going to simplify what's inside the absolute value. So I have the absolute value of 2x, and then plus 4 minus a negative 6 is plus 6. That gives us plus 10, is less than our 0.05. And then remember from algebra that when we have the absolute value less than a positive number, I can write that as a double inequality of negative that 0.05 is less than, drop the absolute values, 2x plus 10, which in turn is less than the 0.05. Now here's what we want to do next. We want to solve this double inequality so that we just have x in the middle. And then once we get to just having x in the middle, we're going to focus on what we need for that yellow highlighted part, which means we need x minus the a. But we need to get it set where we just have x in the middle before we can do that. So here we're going to subtract 10 from all three parts, and when I subtract 10 from all three parts, I get our value of negative 10.05 is less than 2x, which is less than, well, 0.05 minus 10 is a negative 9.95. Now I'm going to divide all three parts by 2. So negative 10.05 divided by 2 gives me a negative 5.025, which is less than x, which is less than negative 9.95 divided by 2 is a negative 4.975. Once we've gotten it where we have just that x in the middle, we look again at that yellow highlighted. We want in the middle of this x minus whatever our a was, and our a is negative 5. So I need to subtract a negative 5 from all three parts. I'm going to write it like that at first, and then we'll simplify the sign. So it's a negative 5.025 minus my a, so minus my negative 5, less than x minus my a, so minus my negative 5, is less than the negative 4.975 minus my negative 5, the a value. Now simplifying each of these, I get a negative 0.025 is less than x plus 5, which is less than 0.025. And now notice how we have the same but opposite values on the left of the double inequality and the right. So I can write this as the absolute value of x plus 5 is less than the 0.025. And now I have that matching that yellow highlighted part, and the value that's on the right of the inequality is your delta. So delta is equal to 0.025. Next, let's do part B. Now part B doesn't have a linear function that it's acting on. It's acting on the square root. So that's going to have to be considered a little bit more. But we're still going to start through with the same steps. So think about the blue highlighted. Think about what each piece the roles play. So f of x is your square root of x, 7 is your L, and 49 is your A. And then of course epsilon is 0.1. So I start with the absolute value of f of x, that's square root of x, minus the L, so minus 7, and that less than epsilon, so less than 0.1. Rewrite it without the absolute value, so I have a negative 0.1 is less than the square root of x minus 7 is less than 0.1. Add the 7 to all three parts. I have 6.9 is less than the square root of x, which is less than 7.1. Now I've got that square root in the middle. I can square all three parts and the inequality stays the same. So I have a 47.61 is less than x, which is less than a 50.41. Now that we've cleared it where we have x in the middle, we go look at the yellow highlighted part. And I want x minus a, and here my a is 49. So I'm going to subtract 49 from all three parts. So I have 47.61 minus the 49 is less than x minus the 49, which is less than 50.41 minus the 49. Simplifying the left and the right, that gives me a negative 1.39 is less than my x minus 49, which in turn is less than 1.41. So notice here I don't have that balance like I did with the linear case. So I have to look at the absolute value of each of those numbers and see which one is the smallest absolute value, and that absolute value is what I take for my delta. Well, the absolute value of negative 1.39 is 1.39. The absolute value of 1.41 is equal to 1.41. 1.39 is smaller than 1.41, so delta is equal to 1.39.